So now in this video I thought we would just take a quick look at what kind of resistor you would need to get a certain amount of current from 5 volts. So let's say we got 5 volts. We want about 1 amp of current to flow. With that 5 volts, we could use a 5 ohm resistor. And this is a 10 watt resistor, which right now is being heated up to about 0.5 watts. And you're going to see the current bounce around a little bit because I'm bumping into the power supply a little bit. These connections, they are low resistance, but since we're dealing with high current, the low resistance even can throw off the voltage, making it to the load and drop the current a little bit. But in any case, we got 5 ohms, and it's heated to 5 watts. It's 10 watt resistor though. You can see how big it is. Then we have over here a 1 watt resistor, positive one side, negative on the other, just like the other 2 resistors. But in any case, we can expect about 0.1 amps, which is the same as 100 milliamps through it, because it's a 47 ohm resistor, and these are approximations. 47 ohm resistor there, we're going to get about 100 milliamps, and it's heating to about half of a watt. It's a 1 watt resistor. You can see its size. Then we're going to zoom in, and you can see this small resistor compared to the other 2. This is a normal size resistor though, the 1/4 watt. And it's going to negative supply on the other pin there, as you can see. And it is also about half its wattage rating. It's a 1/4 watt, but it's heated to about 1/8 of a watt, a little shy of 0.125 watts. 220 ohm resistor. It's letting through about 23 milliamps of current. So you can see about the maximum current you'll get from these 3 resistors, about 23 milliamps. And then about 100 milliamps is where you want to stop. And then 1000 milliamps, which is the same as 1 amp with this large resistor. So now when you're talking about wattage, you're really talking about heat. And you don't want to touch this 10 watt resistor right there. It's really hot. Generally, they should all be getting about the same temperature. But this one has more surface area, will probably burn you more if you touch it. But in any case, when you're dealing with heat, of course, thermal cameras are really nice, as you can see there. So we can either do the color version, and you can see it is relative though. So it's picking up more heat from the large one when you got the smaller ones in view there. But looks like they're probably about the same heat. And this isn't completely accurate, but I think we are looking at maybe about 400. You can see every once in a while above 400 degrees Fahrenheit. But if I do my hand, and I don't want to touch that resistor, I can feel the heat coming off it. It says about 122, and I bet it's only like 80 or something. So we can't assume this is accurate at all. I'm definitely not 122 degrees on my hand. And there you can see how cool my finger is compared to the resistors. But if I get close to my finger, then it turns the color like that. So there's quite a bit to understanding what the readings are giving you. We can also do this color scheme right there if you like that one better. You can see how much cooler my finger is. It's blue, looks very cool, and temperature wise. And then we can also do the white right there. So yeah, my finger's not even showing up at all when we got the resistors. But if you just got my finger compared to the background, now it's really white, whereas the others aren't. So when it comes to the color, it is relative. Now, that's it for this video. I thought I would do a fun video. When you learn about wattage, the heat being generated by components, a lot of it's mathematical, but it's good to actually look at the heat with the thermal camera if you can. That camera, it's I think was $350 when I bought it. So we can expect this to drop about 1 amp when I pull this resistor right there. And now you can see we got about the current that we expect. So either this has slightly more resistance than we thought, or because of the current we're dropping enough voltage there where it dropped below providing 1 amp. Because you can see with these two we got about 0.127. I bumped the power supply, so it moved a little bit more. So you definitely don't want to touch that. You're going to burn yourself really bad. I accidentally touched one of those before, and it really hurt bad. This one probably would hurt really bad too. right there. And the smaller one, since it has less surface area, I don't think, I think your fingers cool it off kind of quick if you touch it. So I don't think you get burnt as bad, but it does kind of hurt. But I would pull this with my actual finger now, right there, and not too bad. So that was the currents that we saw according to this power supply. This power supply isn't completely accurate with the current, but it's usually not too bad. It's usually about 0.2 milliamps or so off, so should be relatively close. But in case, that's it for this video. Hope you enjoyed. Make sure you check out one of the other videos I posted on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.